Hi everybody, you can see here I've got assignment 4 opened up in Unity version 6. So currently the assignment only works in version 6, so you'll need to update your Unity editor to version 6000 if you want to complete the assignment in its current state. I'm trying to get it to work in an older version of Unity, but I'm not having much luck. I'll keep you updated as things progress. Okay, so if you've opened up the assignment in version 6 of Unity, you'll want to go to Scenes, click the sample scene, and you'll get something that looks like this. So in this assignment, we're using multiplayer play mode so that we can simulate having multiple players on a single computer. So you're going to want to activate that. It should already be active for you, I believe. If it's not, just go ahead and do Window, Multiplayer Play Mode. This window should pop up over here. It lets you set up to 4, or lets you simulate up to 4 players on one computer. Our assignment is strictly 2-player, so we'll activate player 2. It needs to do some work here. Okay, and when it's done doing its work, you'll see that another view opens up over here. And so this is the simulated other player. We don't need this right now. I'm just going to move it off my screen. Okay, so I'm going to show you a completed version of the assignment. The code that you need to edit is in the A4 folder, and it's the player controller script. And so when you open up the script, you're going to want to read through the code in the script, paying attention to the comments, especially in the section, sorry, not that section here, the fields used by the remote player controller. And so in this assignment, we're trying to update, in a view, we're trying to update the position of the other player. And so I call that the remote player in this assignment. And so the fields that are relevant to controlling the position of the other player are found in this section here. So from here up to here. So the way that the assignment is set up, I think this is set to mode teleport. If it's not, you're going to want to set it to mode teleport, so I'm going to do that now. And use dead reckoning should be set to false. In the assignment, you're going to be updating the position of the remote player in 2 different ways. And so every time a network update arrives, if you've got the mode set to mode teleport, you're just going to teleport the position of the remote player to the new position. And so if the time between network updates is very long, it's going to look like the remote player is jumping from location to location to location. So with remote player set to mode teleport and with use dead reckoning set to false, I'm going to save that. When you save something, wait for Unity to compile and update the domain. It also has to update the remote domain, so wait for it to. And once it's updated, you can go ahead and try running. Okay, so to open up, to start the game on one screen, or I guess in one window, you'll click Host. So a host is a client that is also a server. So that's going to be one of our players. And so whoever the player is, their avatar is always in pink. And so here you can see that the avatar is following wherever the mouse pointer is. If you click off the screen, the player continues moving, but it walks back and forth around the position where it was when you clicked off the screen. Okay, so I'm just going to let this guy wander back and forth. Over here, I'm going to start the second player. So the second player, you're going to start up as a client. And so here I've got control of the pink player as well on the second, for the second player. And now you can see the blue player is the pink player on the other screen, right? And so you can see that the blue player here is jumping back and forth roughly once per second, right? So every time a new network update comes in from the pink player on the other screen, we're going to update the position of the blue player on our screen over here. You can also see that on the right-hand screen, the blue player is following the pink player on the left-hand screen. And it's just jumping from position to position to position, right? So it's got this stop and go motion. And so that's the motion that you should get when you are teleporting the remote player to its most recently updated network position. So to its most recently updated position. Okay, so let's stop that. Okay, so if mode teleport is set to correct, and then this is going to apply a smooth correction. And so every time a network update of the position comes in, we're going to smoothly move towards the new updated position. And we're going to do that at this speed here, or at a maximum of that speed there. So that's the maximum speed that we're going to move the blue player at. And so with mode correct turned on and dead reckoning set to false, save that. Wait for Unity to compile and update. When we run that, instead of jumping from location to location to location, the blue player is going to move smoothly from position to position to position. So on the right-hand screen, you can see the blue player is following the pink player. It's 1 second behind because our network updates are coming in at once per second. But it is going from position to position basically in a straight line, right? At some at a maximum speed of 3 in this assignment. Okay, so we'll stop that. So let's switch this back to teleport and turn dead reckoning on. Okay, so when we teleport from position to position to position, and then whenever we teleport to the newly updated position, we wait for the next network update to arrive before we teleport to the next position. So instead of waiting for the next network update to arrive, we can guess at the direction and speed at which the player was previously moving at. So what's going to happen is we're going to remember the remote player's previous position. And so this is the true position. So this is the position that was updated to us by the server. We're also going to remember the remote player's current position. So that is the most recent network updated position of the player. So given these two positions and given the time between network updates, we can estimate what the velocity of the player was between those two updates. So the time comes from these two values here. And so the previous network update time, that was the time at which the previous network update arrived. The current network update time was the time at which the most recent network update arrived. So if you subtract these two values, you get the time between the last two network updates. This value update consumed is set to false when a new network update arrives. Once we're done processing the most recent network update, we're going to set that value to true. Okay, so let's see what happens when we are using teleportation with dead reckoning. Make sure we save. Okay, so here we're using teleportation with dead reckoning. Okay, so watch the position of the blue player on the right-hand screen, right? And so you can see that it's moving from position to position to position, but instead of jumping from position to position, it's now, it continues moving in a straight line when it gets to its new position, right? And the direction that it is moving in is determined by the previous two network updates, right? So if your motion is mostly linear, it actually works reasonably well. As soon as you make a turn, though, it tends to move in the wrong direction. But that's because the network updates are coming very slow. So they're coming once per second in this case. If you reduce the time between network updates, the motion gets much better. Okay, so let's see what happens if we use dead reckoning with smooth correction instead. Okay, so on the right, you can see that if you follow the motion of the blue player, you can see that using smooth correction, it's better than teleportation. The estimates are still generally incorrect, so it tends to overshoot, but it's much better than the motion that's produced with teleportation and dead reckoning. And you can also see that it's not the estimated position of the blue. So the location of the blue player on the right-hand screen, it's actually not terrible, which is kind of surprising because we're only updating. It's only ever getting updates once per second, and so the motion's not really that bad, even for a very, very slow network update rate. Okay, so if you want to see what happens, if you want to adjust the network update rate, you can do that. So under Network Manager, you'll find the tick rate. So the tick rate is how often network updates are sent out. So a value of 1 means once per second, which is actually quite slow. Right? If you increase that tick rate to say 5, which is actually still quite slow, even with teleportation, you'll see that with teleportation and dead reckoning, the results are actually surprisingly good. So if you change the tick rate, you have to save the scene. Otherwise, the other instance won't see the changed tick rate, and it'll complain that the network settings don't match. Okay, so after saving the scene, we can go ahead and run this. Oh, sorry. Are we using? Oh, we're using correction. I'd like to use dead reckoning. I'd like to use teleportation instead. Okay, so teleportation with dead reckoning, updated 5 times per second. Right, and so look at the if you watch the motion of the blue player on the right-hand screen, you can see that it's surprisingly accurate. It's a little bit jerky, so we're there. You can still see the artifacts of teleporting from position to position, but it is actually surprisingly good how well it follows the pink player on the left. And if you switch teleportation to correction, the results will become even better. Finally, if you change this tick rate to a much more reasonable rate, so something like 20 times per second, and you're using correction, the results are correction with dead reckoning. The results are quite good, at least for this particular assignment. There's one other thing you might be interested in playing around with, I think. So if you go under prefabs, you'll find the player. And so for a network object, for a network object that is using Unity's network transforms, you can set the settings for the network transforms. So you can see here, this is a 2D game, so we're only updating the X and Y position of the object. We're only updating the rotation about the Z axis for the object. We're never updating the scale. Here, the position thresholds, the position threshold is set to 0. Normally, it's not set to 0. So by default, it's set to some small value. And so the position threshold, if the position of the networked object changes by less than the threshold value, Unity does not send the network update. By setting the position threshold to 0, this forces Unity to send the update even if the networked object doesn't move. If you set this to some non-zero value and you don't move the player, you'll be able to observe the effects of the negative effects of dead reckoning. So here I'm going to set the position threshold. It's still a small value, but if I hold the pink player stationary, Unity won't send the network updates. So let's set it to that and save our scene. We're using teleportation with dead reckoning. The dead reckoning part is the important part here. Let's play the game. So remember now that we've set a non-zero threshold for the position. If the pink player doesn't move, Unity won't send network updates. Okay, so over here on the client, I'm going to move the pink player around a bit. Then I'm going to stop and notice that the blue player keeps on moving. Right? Why does the blue player keep on moving? Well, because we're using dead reckoning. And in dead reckoning, we estimate the speed of the player between network updates. So when we stop, Unity's not sending any network updates. So dead reckoning simply thinks that the player is going to keep on moving in the direction that it was moving previously. So again, we stop here, and you can see the blue player is just wandering off. Right? And so here you can see that dead reckoning produces the wrong result if you're not regularly updating the position of the remote player. Right? As soon as you update the position of the remote player, I think we're using teleportation, and so it teleports back immediately. Right? And so there we go. Yeah. So I've set it intentionally to 0 for the assignment. So that you don't have the effect of the player of your remote avatar just wandering off the side of the screen. I think that's all that I have for you. That should get you... Oh, let me explain what you want to edit in the assignment. Okay, so in the assignment, again, it's important that you read the comments. You familiarize yourself with the fields that are being used. So here we go. So here's the regular update method that you're used to for game objects in Unity. So you know that update's called once per frame update, which is the default value is 30 times per second. So the isLocal player, if you're controlling, is basically the player controller that controls the pink player, right? So on this screen here, when you're controlling the pink player, it's the isLocal player is true. So we're calling update local. Update local simply grabs the position of the mouse and has the player follow the mouse. If you're not the local player, so in other words, if you're the remote player, so in other words, if you're the player on the other screen, on this screen we're going to call remote update, right? And so in remote update, I think I just showed you the solution for one of our methods. But anyway, in remote update, this is where we are controlling the position of the blue avatar. So if we have already consumed the most recent network update and we're using dead reckoning, we're going to call the dead reckoning function right here. If we haven't consumed the most recent update, then we are going to either teleport to the new updated position, or we're going to smoothly move to the new updated network position. And so in the assignment, there's instructions on how to fill in these methods here. And so those are the only 3 methods that you actually need to touch. I think all told, there's probably something less than 20 lines of code that you need to fill in. So read the assignment carefully, follow the instructions, and I think everything should go smoothly. All right, so good luck. If you have any problems, feel free to reach out to me. Come to office hours next week, and I'm happy to help you out.